In this video, we'll apply oxidation-reduction reaction principles and thermodynamics to see how batteries work. The chemical reaction that occurs in the battery converts chemical energy to electrical energy and is a spontaneous reaction. For a battery to work, two substances with a different ability to lose electrons are connected together. A battery is also called a voltaic cell. In an electrolytic cell, electrical energy is supplied to make a non-spontaneous chemical reaction occur. So stop the video and answer these questions. And here are the answers. 5 out of 5, good work. Electricity is the flow of electrons. The flow of electrons is due to a difference in potential. Current is the number of electrons that pass a point in a certain period of time. High current is like a lot of water flowing through a fire hose. Low current is like the low flow rate through a garden hose. Or if you remember dial-up internet connections, dial-up is low current, whereas broadband is high current. Voltage is like pressure. Pressure is the force that pushes water through a hose. Voltage is the force that pushes electrons through a wire. Resistance is like the nozzle on a hose, which controls the flow rate and the pressure. So resistance changes the voltage and the current. Energy is related to the amount of voltage required to move a charge. Power is the energy used or produced per time, which is also equal to current times the voltage. So let's make a battery, in this case a zinc copper battery, and let's see how it works. Now we have two electrodes, a salt bridge, and two containers which contains the metal ion solutions. So stop the video and label the following items and show the direction the current flows and the half reactions and the overall reaction. Here are the answers. Zinc loses electrons easier than copper, so the electrons will flow from the zinc to the copper. The more active metals where oxidation occurs, that's going to be the anode. The less active metal is where reduction occurs, that's going to be the cathode. Combine the two half reactions and we get the overall cell reaction. To determine how much voltage the zinc copper battery produces, we need to look at the standard reduction potential table. The reduction potential for copper 2 going to copper is 0.34 volts. Zinc is being oxidized in the zinc copper battery, so we need to look at the reverse or reduction reaction, that is zinc 2 going to zinc. The reduction potential is minus 0.76 volts. We can calculate the voltage produced by this cell by using this formula. The zinc copper battery produces 1.10 volts. Another way to calculate the voltage produced by the zinc copper battery is to use this formula. We know that copper 2 plus is being reduced and zinc is oxidized to zinc 2 plus. The reduction potential of zinc 2 plus going to zinc is minus 0.76 volts. The oxidation of zinc to zinc 2 plus is plus 0.76 volts. So add the reduction potential to the oxidation potential and we get 1.10 volts. Now, E cell for a battery should be positive because the battery reaction is spontaneous and delta G is going to be less than 0. So let's review some battery concepts. Stop the video and answer these 3 questions. And the answers are, good work. The voltage we calculated for the zinc copper battery is for standard state conditions. As we use a battery, we know the voltage drops because the battery discharges. So stop the video and answer these questions about a discharging zinc copper battery. So here are the answers. And here's a picture of a discharging battery. So red is the standard state conditions, blue is while discharge is occurring. Note that the zinc is being oxidized to zinc ion and the copper is being reduced to copper metal. So devices need a minimum voltage to work, so a battery is dead when it no longer produces the minimum voltage to run a device. We can calculate the voltage of a discharging battery by using the Nernst equation. So let's calculate the cell voltage when 10% of the zinc copper battery is discharged. First, we have to do a chemical calculation to figure out how much copper ion and zinc ion are in the solution. Then we can apply the Nernst equation. When 10% of the zinc copper battery is discharged, note that the cell voltage is only dropped from 1.10 to 1.097 volts. So stop the video and you do B. And the answer is, stop the video again and you do C and D. And the answers are, for D, we want to solve for the ratio of zinc ion to copper ion, which is 24:25 to 1. That gives a percent zinc of 99.9%. That means the battery is 99.9% discharged. So the zinc ion concentration is going to be 1.999 molar. Copper ion concentration is 0.001 molar. Let's take a look at a battery you've seen before. Alkaline batteries are used in remote controls, flashlights, smoke detectors. So stop the video, take a look at the reactions that occur, and answer these questions. So here are the answers. The first reaction is an oxidation, which is the reaction that occurs at the anode. The second reaction is a reduction, which is the reaction that occurs at the cathode. And adding E oxidation plus E reduction gives us the voltage the battery produces. The lead acid battery is the rechargeable battery in our cars, so stop the video and answer these questions. And the answers are, here are the reactions that occur in a car battery. Note that lead oxide is the cathode and lead is the anode. So reverse the second reaction. The cell voltage is under standard state conditions. A car battery uses 18 molar sulfuric acid, so the cell voltage is 2.11 volts using the Nernst equation. And 6 of these cells connect in series gives a 12-volt car battery. The first electric cars ran on lead acid batteries. This calculation shows the amounts of substances for a 200 amp hour battery. The Tesla Model S uses a lithium ion battery. One problem with the lead acid battery is it's very heavy, so new batteries are using lighter weight substances. You're probably using a lithium ion battery right now. Look what the cathode is made of. New electrolytes are being developed for lithium ion batteries which are not flammable. Companies are making lithium ion batteries safer and more reliable. The lithium air battery has a lot of potential but has some challenges. Compare the energy density of a lithium air battery to a lithium ion battery to a lead acid battery. Here is another comparison of energy density. The lithium sulfur battery has a higher energy density than lithium ion batteries. The lead acid battery has the lowest energy density. Look what has the highest energy density. If you ever play a battery trivia game, this will be a good table to use. California got about 34% of its electricity from renewable sources in 2018. But there has to be a way to store that electricity when the wind isn't blowing and the sun isn't shining. So there are companies that make storage batteries to store that electricity. Here's another company that makes batteries to store electricity. Researchers are working on a redox flow battery to store electricity. And here's another company working on batteries to store electricity.